Okay, so a very good afternoon to one and all present here in this class. So in the last class I was taking the class and we discussed about the two modulation schemes. If you remember, I hope the sound is clear and the slides are also visible. So we discussed about two types of modulation schemes, like the amplitude modulation and the frequency modulation in the last class. Okay. Now in today's class we will be discussing about the amplitude shift keying, and in case of ASK we can find that this is a type of modulation where the message is considered as the digital signal instead of analog. In this case it is digital signal. Okay. Okay, thank you Shobhik for your response. Okay. Now there are different types of digital modulation. So I want to focus here 2-3 things. So when you have seen the modulation was the basic conversion of the message into carrier, that is a wrapped carrier, and it was of two type. One was the analog modulation and second one was the digital modulation. Okay. Now the example like AM, that is the amplitude modulation, and the FM, both the things we have done, because modulation and demodulation of AM we have done using the octave code, and modulation of FM also we have done in the last class. So these are the analog type of modulation. Now what you have seen, this in this analog modulation, what is the definition? That is, the message signal is analog and the carrier signal is also analog in this case, because the message you have taken one low frequency sine wave and the carrier you have taken is a high frequency sine wave or cos wave, whatever is the frequency. So this is the analog. But whereas in case of digital modulation, so digital modulation it will be like, it can be like ASK. What is the full form of ASK? You can see here, amplitude shift keying is the full form of ASK. Okay. Second one, another thing is FSK, that is frequency shift keying, and PSK, that is phase shift keying. Now all these cases, these are all, apart from that other things are there like QAM, quadrature, amplitude modulation, okay, or QPSK. You can find out in between this, it should be quadrature phase shift keying. This is another type of PSK. Now in all the cases, the message signal for this type of digital modulation yes, I can change the color of the pen. I hope it is visible. So the message signal is here is digital in nature, okay, and the carrier signal, so I am talking about digital modulation. In that case the message signal will be digital in nature and the carrier signal will be analog in nature. I have already changed Madhusri, I think it is visible to you, right? Previously it was red, now I have changed. So in case of carrier signal it will be as it is analog. Madhusri, is it visible now? Okay, 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 thank you. Now both the cases, and this case it was message was also analog, A for analog, and carrier was also analog. Okay, this is also some cos, cosine or sine, whatever is the signal we used for message and carrier. And for this case, if I see, the message will be in the form of, suppose 1010 is a data, and the carrier will be, previously it was the high frequency carrier. So there is no change in the format of the carrier, but in case of message, instead of previously used sine or cosine function, you need to generate some data. Okay, you need to generate some data. I am just, those who have joined recently, I am telling once more. Okay, like what I told, modulation technique, you know, modulation, in that modulation technique you use two signal, one is the message, another is the carrier. There are two types of modulation I told you, one is the analog modulation, another is the digital. Broad classification. Like here AM is a kind of analog modulation, FM and maybe PM is there. So this FM and PM are known as the angular modulation. So for this type of modulation, the message signal was analog and the carrier signal was also analog, but the difference is that the FC, the frequency of the carrier, was much more than the frequency of the message. That was the essence of using the modulation. Okay. So in this new technology or new modulation scheme, you can find the message itself is a digital kind of signal. Okay, and there is the carrier signal which is analog high frequency. So whatever is this same carrier you need to generate, but previously you have generated some cosine signal using some mathematical equation, but here you will be using some bit generation. That is the difference, and these are basically the types of digital modulation technique like ASK, FSK, PSK, QPSK, QAM, etc. Now in the same picture, because every time I show you the same picture, so the message signal you will be, I am changing the color once more. Now I am making it red. So in this message signal, what you used, the information or the message signal you will be using which type of data, like it will be 1011. You will be, instead of AM, you will be using some ASK transmitter. You will be using the same carrier. What is the form of the carrier signal? High frequency sine or cosine wave. Okay, there is no change about this. Okay, so this output will be ASK output or ASK waveform that you will be obtaining at this cross section. Okay. So as I told you, these are the fundamental type of digital modulation scheme. Now we will be starting with ASK. So ASK you will be learning and normally in the theory class. So ASK is a type of modulation. It is also known as, please note it down, it is also known as OOK. In optical fiber communication we prefer to use OOK. Why? What is the full form of OOK? It is known as the on-off keying. Okay, OOK means on-off keying. How the nomenclature is like that, I am just telling you. Please read out the sentence. The binary symbol 1 is represented by transmitting the carrier, that is the presence of carrier, okay, and binary symbol 0 will be presented by not transmitting the carrier signal. Okay, so that is the primary difference. So let us see the snapshot, you will be able to understand. So suppose the data is like, the data signal is like, suppose this is the reverse polarity has been done. So maybe it is considered as 0 0, that is, suppose this is considered, or you can think of this is 0 0 means there is the data 0. If the data is 0, what is the theoretical equation, if the data symbol is 0, then no transmission of the wave, that is the thing. If data symbol is 0, there will be no transmission of wave during that period, okay. Every bit duration is t, so it will be the better choice. So suppose this is the carrier, you can see here the first one is which type of signal is this? The first one is the carrier. So you can see here this is the carrier signal. The first one is the carrier signal, you know. The second one is the data or the message signal. So this is the 0 duration, this is 1 bit period, okay, 1 bit period, okay. And you know what is the frequency or the data rate? We call it as like this. So if the TB, so if you are using a very high frequency or high data rate signaling, it does mean that the bit period, so if the frequency is getting higher and higher, the bit period will be getting smaller and smaller. So it will be very much congested in nature. Now C is the thing, it's correct. This is the ASK modulated signal. C is the ASK waveform. So what the theoretical definition? So when data is 0, there is no signal at the output. So absence of signal. During this phase, I can say this when the data is 0, it will be absence of carrier, okay. And when the data is 1, the next TB duration, there will be presence of carrier. How? This is the way we differentiate. Now next bit is 0. Then again absence of carrier, next bit is 1, presence of carrier. Now if I show you, if I give you one example, can you do it by yourself? Suppose I am creating a white screen. Suppose you can do it by yourself for sake of your understanding. So for ASK, the data I am giving you, you draw the picture and send me in WhatsApp. The data is 110101. So this is the data. Carrier, you know, it is a high frequency sine or cosine kind of signal. Now can you tell me, the question is draw the ASK waveform. How will you draw it? It is easy. Can you please draw and send me? I am also drawing it here. So when you are drawing it, the axis will be common, okay. The starting point will be common, okay. So the data is suppose 1, the bit period is same, then 0, 0. This is suppose the bit period. The drawing is not too much perfect. So this we are replacing. So this is suppose 1, 1. 0, 0, the voltage is 0, then again suppose this is 0, then again 0, so 3 consecutive zeros are there, and then it is 1. The carrier will, so this is the data or the message. The carrier will be like that, it is a continuous wave signal that is propagating through the x axis or time axis. Okay. So x axis is what? Time. Now I am asking you how the ASK waveform will look like. Many of you are sending the output waveform. See properly. How many cycles are there? That same thing will be replicated in this case. So suppose there is one cycle here, okay, or there will be another cycle here, okay. From this to this there is no, so you just map this point to this point. So during this phase there is no signal, and then in the next bit you will be again sending suppose some waveform. So, whatever is the carrier that is going to replicate it during this period, but meanwhile this space is not used, that is no carrier is there in this because 3 consecutive zeros are there in between, then you have 1. Please correct the signal and resend it. See one thing I want to show you. You see, when 0 it is 0, see this one carefully, do not draw whatever you like. So, the way it is drawn, suppose 2 cycles are there, same 2 cycles will be there, just replication of this one, it is not arbitrarily you are drawing something. Shobik, I hope you have seen, okay. So, not arbitrarily, so the time period will be common, or while you are drawing for the final examination, please take care of this. I am just removing this, or I am just erasing once again. So, whatever is the waveform here, same thing will be exactly replicated. 2 signals in 1 bit, yes, 2 signals because 2 complete signals in 1 bit. It may be more than 2 signals. So the whatever, if it is you have drawn 4 signals, then it is not mandatory always it will be 2 signals. Okay. Yes. So take care while you are drawing, please take care. Okay. You have drawn in a freehand basis, but when you are drawing in exam, you do it whatever it is there. Okay. Now, so when we are all, yes, Ongira, Orindam, okay, all of you have sent, Amit, Shobik, many of you are sending the snapshot, Archana, okay, lots of the Ongira, all the people are sending the snapshots, fine. Now, our objective is to what? Our objective is to code this one. So, first what is the objective of today's lab? Number 1, you have to plot the message signal. What is that? That is the digital data, okay, digital data. Second one, you have to plot what? The carrier signal. That you have used previously, you have already plotted simple cosine wave, the sine or cosine wave. Okay, and third is the plotting of the ASK signal. So, 3 plotting will be there. Okay. So, how we have started? So, what is the simplest one? The frequency of the carrier, that is FC is the frequency of the carrier, FP is the frequency of message. Why P we are talking about? P is, okay, I am changing the color, just a second, sorry, I forgot, okay. Shall I have to write it again? So, what I wanted to, the first thing you plot the message signal, that is nothing but the digital data. I am simply taking 10 10 10 like that, it is a simple oscillating waveform. Second, you have to plot the carrier signal, in short I am writing, okay, that can be either cos or sine wave. And thirdly, you have to plot the ASK waveform or ASK signal, that is the OK signal that you can plot. Now, how we are reflecting all these things? What are the inputs we are taking? FP is the frequency of the message. Previously, we have taken FM, frequency of the message. One second. What is the difference? I have already told you, Shuparna. In case of analog modulation, the message and carrier both are analog sine or cosine wave. In case of digital modulation, the data or the message signal we are taking is digital in nature, means you need to plot in form of ones and zeros. That waveform you need to plot. I hope you can see here. The waveform, you can see it is not low frequency analog, it is a message signal will be like this. So, it is in the digital form. Shuparna, I hope the doubt is clear. And the advantage of digital means, you know the advantage, the noise effect is more, the effect of noise is less. Along with that, you can do some encryption, and nowadays all the what I told, like LAN, different modems, they are using the digital modulation technique only, but only for the entertainment purpose we are using some FM channel for listening to music or like, because that the digital modulation is much secure. Whatever the mobile phone you are using, all the signals, the modulation that is going through, that is happening in your mobile phone is basically the digital modulation. Suppose you are using your GSM phone, there you are using certain digital modulation technique, not analog modulation technique. So, analog is not secured, the bandwidth is very low in that sense, and certain noise effect is very high. So, only for specific entertainment purpose we use the broadcasting FM or AM broadcast, we use analog. So, that is much more in earlier days we use that one. Present days even ASK FSK is very much backdated now. We are using QAM, or even in the optical signal also we are using QAM. It is not only the electronic signal. Shuparna, I hope the doubt is clear. So, anyways, so the FP is the frequency. So, what you did, you have taken the amplitude and frequency of both the carrier and message in the AM and another type of FM program, right. So, here FC is the sine wave carrier, you have taken sine wave. FP, so both are the frequency you are taking as the input from the user, and then the amplitude, suppose the two amplitudes of the carrier and message, that is a message means carrier is fine, binary pulse message is basically the message. So, suppose you are giving, suppose what is the value you can give, carrier means you can give, enter the value 100, or whereas the pulse frequency is very because it is a message signal, right. So, you can take it like 10 or 20 something. So, it is greater than this. So, that is the thing you need to remember while you are giving or while you are entering the data. Okay. So, the rest part, you know, you have mentioned the time scaling the way you always do. Now, you have assigned one variable C, and here the amplitude is the AMP. You can use simply star also, because amplitude is constant. Without using dot you can also do, but they have done. So, you can use that. And you have plotted this one. This portion is for the plotting purpose, because you can see three things you are going to plot, like the message, then carrier, then ASK. So, within the single column and 3 rows will be there, right. So, it will be 3 row single column, and the first position will be the carrier. So, the plotting idea is like that only. So, subplot, before plot you must write the subplot, and the positions is you can frame it according, you can horizontally also frame it, but I have taken this one vertically. So, because the alignment that I wanted, because all the things are aligned, because if it is starting the carrier, same thing needs to be reflected here, right. So, in this portion, if you are having a carrier, same, if the carrier is moving higher, the ASK will be moving higher, the exact replication. So, we cannot put the things in the horizontal manner, we have to take these things in the vertical manner, because time is an important factor in this case. The second thing that I want to focus, I have given the bracket but I have not written, the binary message plotting. So, you need to plot the message signal here. So, which type of message? The binary. হ্যাঁ স্যার, স্যার ক্লাস হচ্ছে। আচ্ছা আচ্ছা ঠিক আছে স্যার, ঠিক আছে, হ্যাঁ স্যার। Okay. So this is the thing. Now when you are plotting the binary signal, what is the plotting? The data I have taken simply 1 0. So you are using an inbuilt function square with 2 pi fp. So what is this? Fp is the frequency of the pulsating wave, because the pulsating wave is 1 then 0 then 1 then 0 then 1. So there will be certain time period t, and fp will be just 1 by tpy, because this is the pulse. P stands for, okay, that is why in suffix we are writing p. Now something we have added, because for this case actually you need to boost the signal, otherwise if you use the square signal, that is the inbuilt function used in MATLAB, it will be something down. Okay, so you have to, clipping and clamping is one concept. I do not know whether you have studied in first year or not. You have to just boost the signal up to a certain amplitude. So we are just doing that, so that you will be getting from 0 to 5, this type of, it's not 0 to minus 5, this way. Okay. Now for this case you will be using this one, and you can find the third plotting is the plotting of the ASK. So how you are plotting? You are simply multiplying, because C is containing a set of values, M is containing, the message means the data is containing another set of values. So both, this is one array. So C is basically one array you can think of, because as it is a function of t, t is taking different values, so C will have different values, and M is also another array. So when you are doing the product operation, you are using dot star concept instead of simply using star. Okay. So in this case you can find this is the third one, plotting of ASK, you are just multiplying this one. So why I am saying like this? So if you are multiplying, suppose I am just changing the color. Suppose b value, for all these b values it is 0. So 0 into something, suppose at this point at suppose time 1, here at time 1 it is suppose 2. Okay. So here the amplitude is 0. So at time 1 when you are plotting here time, so 0 into 2 will be 0. So that is why the output here is 0. Okay. So whatever is the amplitude here and whatever is the amplitude here for a particular time, that two magnitudes must be multiplied. So as the amplitude is 0 here, not only here, during the whole region it is 0. So 0 into something is going to give you 0, right, during the whole phase. So that is why we can find out, you can get C if you are multiplying A dot star B for this case. Okay. Now you can simply implement this one using this dot star concept. Okay. And here also subplotting, the third position will be the ASK, so it will be 3 1 3. Then you will plot the, this W is containing the ASK, and then X axis level, Y level, and ASK, it should be ing, it should not be ed. Okay. Now when we talk about FSK, when we talk about FSK, we can think of this, it is another type of ASK. You can think of that previously you have not sent any signal when you have sent 0. I am repeating once again, please listen carefully. this is a FSK will be another modified kind of ASK. Here what you have done, when you have sent 0, no signal has been transmitted. When you have sent 1, some signal, the carrier signal you have transmitted. But in case of FSK, you can think of it is also known as the BFSK, that is binary frequency shift keying. Okay. And what we are doing here, two binary values. What are the two binary values? Either it can be 0 or it can be 1. So frequency 1 is going to represent 0 and frequency 2 it is going to represent 1. Previously you have the only 1 is going to be replaced by one carrier, but here you can see the frequency the 0 will be replaced by another frequency. Okay, it may be higher or lower depending on the situation. So when you use FSK, FSK is much better than ASK. So it is much susceptible to error, rather you can say susceptible to noise. That's why FSK is much better. Okay. There are different examples where we have already used the FSK technology. Now we are using PSK. Now this is the mathematical equation. If you think that S is the transmitted FSK signal, so when the binary 1 will be there, you are sending this A cos 2 pi f1t. For this case, suppose this will be 1, the reverse thing, and when you are sending binary 0, it will be 2 pi f2t. So this is the way they have sent the 2 bits using 2 different frequencies. Okay, you have used previously in case of ASK, you have used only one frequency for binary 1, and for 0 you have not sent any carrier, but in this case for 1 you have used one frequency, for 0 you have used another frequency. So see the waveform how it looks like. So it may not be a pure 1010 value, the data is suppose that data is suppose 0 1 0 0. So this is the grid on, another command we use in the MATLAB, grid on. So if you use this one in the MATLAB, I do not know whether it is applicable in Octave or not, because Octave is somehow some lucid version of MATLAB. So this type of gridding will be there, like in graph paper you have seen grids are there. Otherwise, how you can define the bit period? Okay. So 0 0, then 1 1 1, because you can say all high and then low, so it is 0. So this is the message, and this is one frequency f1, and you can see which one is, can any of you tell that which one is having higher frequency, f1 signal carrier or f2 signal carrier? I need the answer, any of you. Which carrier signal is providing higher frequency? Because in this case you are using two carriers. Here also this is one carrier, this is second carrier. This is the message, this is carrier 1, this is carrier 2. So can any of you tell me that which carrier is having high frequency and which carrier is having low frequency? Yes, correct. So f1, because the time period is less, so f1 is higher frequency compared to f2. Okay, that is correct. So what you can see here, many of you are answering, yes, that's correct. So when you are sending 0, so when the data, so the mapping will be like this. So for this duration, which carrier shall we send? This one or this one? For the 0, which carrier shall we send? This one or this one? The low frequency. So that's why if you are sending 0, you send the low frequency. Previously it was totally absent in case of ASK, but here in case of FSK, when you are sending 0, you will be sending some low frequency. Okay. And in the next bit, when you are sending 1, you will be sending some high frequency. So this has been replicated here for this bit duration, whereas as it is 0, this has been replicated here, right? Is it clear to you? So if you continue like this way, 0 0 means again 2 cycles of low frequency, again 3 ones mean consecutive for 3 bit period high frequency, and then again 0. So again a low frequency cycle. Now 0 stands for low and 1 is for high, but in many situations, in many books rather, if you refer, they have considered the reverse thing. So you can find why the name is like that, frequency shift keying, why the name is like that. So you can find there is a shifting in frequency, right? So in this signal there is a shifting in frequency, sometimes it is sending low frequency, sometimes it is sending high frequency. So there is a shifting in frequency, that is why the nomenclature is like that, frequency shift key, right? Okay. Now how to incorporate this one, how to incorporate this one in MATLAB, let us see this one. So other things are the CLC, close all, clear all. What are the inputs you are taking? These are the inputs you will be taking. So what are the inputs? Frequency of the carrier 1, okay, first and second. You can say this is basically the FC1, this is FC2. Enter the frequency of the periodic binary pulse means what is this? FP. Enter the amplitude of both keys, this is basically the AMP, right. So these are the typical inputs you are taking from the user end, okay. Then what you are doing, what is the next step? You need to plot. So here what will be the plotting type? It is not, because you have seen, so can you tell me what will be the subplot for this? So when you are subplotting this one, definitely the subplotting will be subplot for this case. If I want to have a picture like this, it will be how many rows are there? 1, 2, 3, 4. So it will be 4 single column, and first position will be the digital data. Okay. For this plotting, the subplot command will be like 4, 1, the second position will be the first, the high frequency carrier. For this, the subplot command will be like 4, 1, 3, and for this the subplot will be 4, 1, 4, right. I hope there is, yes, this is the thing. I hope you have understood. If you have understood the previous day thing, then you can also capable of understanding this thing, okay. Now in the today's assignment, I am opening the assignment also, the FSK you need to plot, okay. So you can take the snapshot, because the next class Nilanjan sir will be taking, and many of you have asked for the PPT, because once I give you the PPT, no, you will not do anything. At least without giving PPT you will at least try, but once you will getting the PPT, you will be storing all these things for the final exam. ও ঠিক আছে, পরীক্ষার সময় সব ম্যাম পাঠিয়ে দিয়েছে, আমি ভালো করে স্টোর করে ফোল্ডারে রেখে দিই, ড্রাইভে রেখে দিই, দেন উই উইল শেয়ার অ্যান্ড অল দিস থিংস, ঠিক আছে। তাতে কি হয়, ইউ উইল নট লার্ন, শেখাটা হয় না। এখন যখন নিজে করবি, ইউ উইল অ্যাটলিস্ট ডু সাম হ্যান্ডস অন, সো দ্যাট ইউ উইল লার্ন সামথিং। আদারওয়াইজ এটা যা আছে ব্যাপারটা আমার কাছে একটা স্টোরেজ হয়ে রইল, আর কিছুই হলো না। এনিওয়েজ আমি পাঠিয়ে তো দেবই, কারণ আমি নিয়ে এগুলো কি করব। ঠিক আছে, আমার এটা হয়ে গেলে আমি the AM/FM along with ASK/FSK I will be sending, okay. Now Amit has already told me, I have seen all those messages, but I have not entertained due to certain reason, okay. So this portion is the thing when you are basically you are plotting the two C1 and C2. You see the plotting of this is the carrier signal 1 you have plotted, this is the carrier signal 2, because how can I tell? Using by observing this FC1 and FC2. By observing these two we can tell that you are plotting FC1 and this is the FC2, okay. And you can think of this is the first 411 they have used, maybe not the same way, the first is not the message, they have plotted in this, that is the carrier 1 for carrier 2 412. So, it will be carrier 1 then carrier 2 then message then FSK, in this order it can be done also. Okay. And ultimately the third one, you are plotting the message is the same data, that is amplitude, you cannot put star or you can put, it will not matter because it is a solid constant waveform, that is a constant parameter, amplitude value is you are giving 5 or so, it is not array. So, it is a square value with certain amplitude mapping or amplitude combination you have to give, otherwise it will give to negative part. And subplotting of the third position I have told you, carrier 1, carrier 2 message. So, the 413 will be the square type of 1010 type of signal, and then the fourth one is this is the important part. Okay. Now, in ASK you have just simply multiplied this one and you have obtained this one. But in this case you just try to listen carefully. This is a loop, you can find it out. Okay. It will be small, end will be small, it is not capital. So, you have used one counter value I. How many values the I will iterate, as if 1, 2, 3, 4, 5, 6, 7 up to 10,000 values. Okay. 0 to 10,000 value, so 1000 value it is going to change. Okay. Now, if the I value is equal to 0, that is the message value is 0, try to understand the concept. If the message value is 0, okay, the ASK mapping is done in this variable Okay, it is the ASK variable, it is denoted in So, in you are assigning the carrier 2 because it is 0, that is why you are assigning the carrier 2 in whereas in the else part you are assigning carrier 1 in That is, in else part means if the message value will be 1. So, if the message value is equal to 0, the modulated FSK will contain carrier 2. Okay, that is a low frequency carrier, and the else means if it is 1, definitely it is. So, in the simple if and else part you can apply, and then you use the subplot command. The fourth position will be what? The FSK signal. Okay, then you have plotting X level, Y level, title as it is. I have not changed anything. So, this is the carrier 1, you can find it here from the graph. This is the carrier 1. This is the carrier 1, means the frequency is higher than this. Okay. This is carrier 2, this is the message or the data, this is 10 10 10 like that, the high low, the color is a bit low, and you can see it here, the high frequency, then it is the low, then high, then low, these things are there. Okay, maybe the reverse plotting has been done. Okay, there is no issues as I told you. So, you can just change the alignment, that is if you give C1 in this place and C2, the alternation will be done, nothing else. Okay. So, this is the way you will be getting the final FSK waveform here. Okay. Now, what is PSK? PSK is known as the phase shift keying. There are different types of PSK, like it is known as BPSK and DPSK, differential phase shift keying, QPSK, quadrature phase shift keying, lots of PSKs are there. So, what is the equation? You can find it out. When there is binary 1, the equation will be as it is, the normal carrier. when it is binary 0, the carrier will be added with pi here. So, if it is added with pi, you know it will be minus of the same carrier, because the phase if you add with pi, it will be minus of this. So, there is one change in the phase value when there is some transition from, because you can think I have not plotted that this is 1, sorry, this will be 1, I am just erasing. So, the thing is that actually the data is here, if you plot the data here, there will be 1, then at this particular position there will be some transition 1 to 0, then 0, then 1, then like that only. So, if there is some transition from 1 to 0 or 0 to 1, you will be having some phase shift, okay. This way or this way, these are the positions you have phase shifting, 180-degree phase shifting has been done due to this equation, because the formulation is like that only. So, you need to create some electronic circuit actually which is capable of shifting the signal by 180 degree. You know how to use inverters using the op-amp 754. We use actually the inverter circuit to do this flipping operation. Okay. Anyways. So the next thing is that I hope I will give you the presentation and you can do it by yourself itself. And the next thing I like to show the octave part. Okay, one thing I like to another show you the computer network, all these things you can do in Python also. So, for sake of one example I am showing here. You can import the NumPy and the Matplotlib library. These two things are very important. So, it is not only that you can ask me, ma'am, only through Octave can we do it, or we can use the other type of softwares like the Jupyter Notebook, or you can online version, the Google Colab you can search. I am just telling you for sake of the clearing some doubts. You can use Google Colab and you just simply log in and you can simply. So, I have done this one. So, here it is already there, CN experiment 1 2, using the Python also you can do it. Okay. So, all the codes I will be providing. So, I am just explaining the thing. Okay, one thing, another thing, I am just opening the window. Okay. Now, for inputs, this is the amplitude modulation, this is not ASK, FSK, but all the things you can do simply using the that is a Python use. Yes, I think it is visible, right? Is it visible? Simply you can do the previously used amplitude modulation using the Python itself. Okay, like you can import the NumPy and these two libraries you can import. You can in this case one thing I like to mention, previously what you have done AC into cos 2 pi FCT, but here the cos function, you can see the cos function or the pi function, these are actually the typical functions that are there in the NumPy. Okay. So, that is why when you are fetching all those things, we can use np.cos or np.pi in those scenarios. Otherwise, the equation is same. And what we did, the time domain we have used like in this way, like the presentation. Let me check how you have defined the time t equal to 0 is to 0.00. So, in this octave it is applicable. When you are using in Colab, you will be using np dot linspace. It is not line space, np dot linspace you will be using. For those who are interested, I am just telling for them only. There is no I am not giving you any pressure. I am not giving the pressure that you please do it in this way only. You can use the Colab as well as you can use Octave, which one you prefer. This is for the amplitude modulation. You have defined the libraries, you have specified the line, that is the time interval. The equations are similar, how you have given the equation of the message and carrier, only the difference is like that. The cosine function you need to take it from the, okay, you have to take it from the NumPy library, all the inbuilt values, that is the cos or pi, okay. So, np.cos or np.pi we will be using, okay, and then you use the simple amplitude modulation equation, then you have subplotted. So, while plotting you have used the matplotlib.pyplot as PLT. So, you are just taking that point PLT.subplot, then plot whatever is the title, then plotting. The color you can change using these values like green or something. The concept is x level, y level. X level we have in the x level we, instead of writing time, I have written like message signal. Then you can see here in this diagram itself that the title will be on the top and the message is a message I want to show, that is why here it is the message is written, or the carrier it is written, or the AM is written. So, you can change all the values, and ultimately 3 subplotting, the subplotting of the message, subplotting of the carrier and subplotting of the AM we have done. And then actually what we have done, we have adjusted, this is the subplots underscore adjust the spacing, the different things are there, right? 3 plotting we have done. So, how to manage the spacing between the subplots, that is you can change the h space equal to 1 to h space equal to 0.5 also, okay. And by changing that value you can see that how the output it will come, like when you are downloading in the form of image, you can see how the spacing in between the subplots are changing by using the, or by varying the h space equal to some variable comment, okay. Now, whatever is the thing you are getting, ultimately you want to save that one in the form of some figure, and in the figure resizing is also required. So, this is the figure, whatever is the get current figure, GCF means the get current figure, and that figure is to be saved in the fig variable. Now, you want to resize the fig variable in this fashion, line 16,9, and ultimately you can save this file. So, if I run this one, it will ask to give the values of different, like enter the amplitude, I have given 5, enter the frequency of carrier 50, enter the amplitude of the message 5, frequency of the message, whatever the values, conventional values I am given, and I have done the critically modulated AM signal like this, okay. So, you can do it by yourself for sake of your thing, and I hope this will be fine. Now, this thing I have already done, I just like to show you in this way. Okay, just wait for 1 second. The Colab part is optional, it is not like that you have to do it in Colab, but you can try if you want. So, because you are using Colab for advanced AI/ML, so instead of using Octave, you can use that one also. So, this is the diagram. I am just increasing the font size a bit. Okay. Let us see the thing. So, what we have done for clearing the command window, closing windows, deleting variable, you can do it. The inputs you are giving, all the frequencies of the carrier and message, and the input amplitude of both the things. We have considered both. If you want to change it, you can change it. Now, first we will be plotting the carrier. This portion of the code is going to give you the plotting of the carrier. The time division I have given, the equation is given, followed by the plotting and subplotting. Okay. So, if I save and I think there is some connection issues. Okay. So, if you just save and run, these three close all, clear all, CLC done. These positions, 3 values you are using for user input. This portion of code will give you the carrier plotting. This portion of code will give you the, I am just giving a space so that you will able to see it. Is a message plotting part, and ultimately ASK signal will be like this. Okay. If I save and if I run this portion, okay. What is a frequency carrier? We take some higher frequency, suppose 100 I am taking. Enter the frequency of the binary, it is lower than 100, it should be lower than 100. So, I can take it like 20. The amplitude of both the carrier and binary signal, I can take it as 5. Okay. So, if I just drag it in this way, so first one the 100, all the parameters of entry are there. So, this is the first is the carrier, then the message, and it has been overlapped the thing. If I download, it will be better. So, if you click here and click the PNG file, it will automatically get downloaded. Okay. So, if you see what is a that is a file that has been downloaded, you can see it here. Just wait for 1 second. I do not know whether it has been downloaded or not. Let us see. Okay. Now you can see whatever the data, the waveforms are there, you can easily see this one. Okay. So this is the carrier, the first one you can just save it, the second is the binary and the ASK is the third one. So you can see the carrier is present when it is high, when it is low the carrier is absent, again when it is high the carrier is present, when it is low the carrier is absent. So this is the way you can find the ASK waveform. Okay. Anyways, so this part is done, ASK is done. Okay, so I do not want to put it here, so because the FSK part is already there, so I am just commenting this part. You can download and you can just save those values, graphs. You have any doubt? I am not observing the queries here. Aryan has said that yes, it is coming. Yes, who has done the FSK part? Yes, Shoham has done the FSK part, it is correct. Yes, Aryan, it is correct. Aryan, it is correct. Okay. So you can do it by yourself because the code I have already shared, the explanation part is already done. So next class will be taken by Nilanjan sir, and please be tuned in the same link. Sir will be coming. So take 5 minutes of break and rejoin here. Okay. Now FSK part I am just want to tell you here. I just copy and paste this part of code here. So clear all, close all, and then FC1, FC2, FP, AMP, the entry of 4. This is for the FSK I am just doing. The two carriers C1 and C2, then subplotting and plotting of two carriers, those two will be the first one and followed by the message and the FSK signal. You can do it with me. Until and unless you do it, it will be difficult because only by copying and pasting the code it will be there, no issues, fun, but if some offline exam happens then it will be problematic. Okay. Anyways, so this is the FSK code. So when you are doing the FSK signaling, the 3 part will be same: close all, clear all, CLC. So there will be 2 carriers, first sign and second sign also. So frequencies of the 2 carriers, one will be higher, another will be lower, and the frequency of the message, amplitude of the signal and carrier both. Then the first part of the code will give you the plotting of the carrier 1. You can see here the plotting of C1 and the plotting of C2. So the first two will be the plotting of C1 and C2 followed by this portion, and then okay, so if you run this one for last portion, you know, it is the FSK plotting I discussed. Okay. So it is asking here for giving the input. So what is the frequency? I am taking suppose 100. The carrier second frequency I am taking suppose 50, because FC1 and FC2 it is 10 I am taking. Okay. And then what is the amplitude of the message and carrier? I am taking it as 5. Okay. You can find it out that how the waveform it is coming. So this is the carrier 1 high frequency, carrier 2 low frequency, and this is the data binary message, the third one, and fourth one will be the modulated, that is the frequency. It should be the frequency. You can change the code you are writing here, that which modulated, that a frequency modulated signal is this. Okay, so carrier 1, carrier 2, binary data, and this one. Okay, so you can do it, and you will be getting, you can just save this one. Got stuck or what? I think. Okay, I think it got hanged. Anyways, I hope you have seen this. So I am not going to torture the octave, not also you people. Okay, you take 2 minutes of break and come back. Okay, NB sir will be coming, and I am just closing this one. All the codes, because I am finished the physical layer, the whatever the experimental part that we are supposed to do, that portion is finished. So whatever the thing we have, I will be sending through this, okay, through the official group, because till now I have not done any classroom. Okay. Okay, so please wait for 5 minutes, sir is coming.
কোনটায় চলছে, ডেস্কটপ না ল্যাপটপ? স্ট্রিম চলছে তো, ঠিক আছে। Okay, wait a minute. Let me just download the PPT first so we can continue. Okay, so let's take another 1 minute break so that I can prepare my PPT. Okay, so last week we were continuing with different commands which are being used in DOS mode for accessing different network related issues, network related understandings, network related systematic information. And we had done with the ping command, like we had seen that when we ping a address, that address related information is conveyed to us through the DOS mode. Like this example is showing that when you ping a specific address or a host ID, that means like google.com, it's sending a 4 packets of 32 bytes and trying to understand what's the speed of this connection and how much time it takes for the connection to reach there, and get an acknowledgement bit for each one of the packet that we are sending, right? A very statistics that you can see here, that's being represented in the lower part, as you can see. Let me just take the pen out. Okay, so this packet sent 4, received 4, lost 0, that means 0%, lost 100%, transmission has appeared. Okay. This way we can include any other commands along with the ping command provided by the ping command itself. When you write down ping only, you get a list of commands that you can use with the ping command itself, and there are numerous amount of commands that are there. We don't need to go to in that details as well. But we will try to understand only the basics of it, because that much only you need to understand in this semester itself. Then we had understood what the traceroute or the trace route command what it does, and we have seen that, as you can see here, that when you try to trace the route of a specific address, you get all the individual nodes that it has connected to and all the internal nodes that's within our own LAN and within the WAN, all the individual nodes that it has reached to get the path, and it has followed the path, that related information you get into, and about how much time it has taken to reach that particular path to get an acknowledgement from that path. You have also got that information in the traceroute command. Then there is a path ping. The path ping is associated with the traceroute itself. It shows up with the all the individual IP addresses, all the individual nodes that it has reached, that it has touched and has jumped to another node for hopping purpose, right? So path ping we have also understood. If possible, if you can reply to me. IP configuration is your internet LAN's IP configuration, that is the link through which you are connected to the internet itself. You have got an idea of that. Your nearest router or nearest switch or nearest hub or nearest bridge, wherever you are connected to, you give an IP config command, that you are getting an details description of the router's IP address along with its subnet mask, along with its default gateway. Then there is GetMAC. I believe this was the last one we had discussed. GetMAC is a MAC address notification or MAC address notifier. Let us understand, let us try to find out what the command does by typing GTMAC, and your physical address, your device's physical address is this one. That's a hexadecimal address that has been provided here along with the MAC address. So this is the TCP IP device. Then your wireless device or your device which is actually connected to the internet, your connecting bridge or the network connecting chip, its own MAC address or the medium access control address, which is a physical address provided by the computer itself, provided by the motherboard, by the device manufacturer itself, is provided here. It's like the, what I can say, subscriber identification module or the SIM card number. It's like that, where each one of the SIM card is associated with the SIM number. Similarly, all the individual computers are connected through those MAC addresses. So there are two different addresses. Let me just close this one. There are two different addresses that every computer need to have for connecting it to the internet itself. One is the logical address Second one is the physical address. So physical address. So logical address is your ID or the IP address of your computer. Your computer mainly has a name on it, say for example local computer. So how do you get that name? You just need to go to your, let me just go back to the desktop itself. So the desktop, let me end this show first. So let us go back to the desktop and right click on it and then properties, and when the my computer opens you can have a detailed understanding of your name of the computer. So it's a desktop H396AB1 that is assigned by the Microsoft Windows itself when it was being installed, and they have provided us with a configuration whether it's a laptop or a desktop. They have automatically understood it's a desktop computer with a pen support. As you can see, it's a 64-bit operating system. That means the chip that has been provided, it's Intel Pentium R processor with G3220 at 3 GHz clock range. It has 4 GB of installed memory. It's a 64-bit processor, x64. That's the later devices that were being introduced by the Intel, and this H396AB1 was automatically assigned. It's a random number that is being assigned by the Microsoft when it was being installed by the okay, Windows, when it was Windows 10 Pro was being installed, it was assigned with this name of this one. It's a randomly provided randomly provided ID that ensuring that no two of the computer provides with the same value. That's the purpose the Microsoft Windows has been assigned with, so that every computer provides a unique ID by default, and obviously you can change that. You can change this by going into change settings, and you can name your computer like the way you used to, but you have to also maintain some of the points, keeping in mind that point should be matching with the criteria set by Windows 10 when it's being named. And it is a part of the work group. Your computer may be a part of the work group, may not be a part of the work group. That totally depends when you are configuring your Windows and your Windows Internet. Okay, so let us go back to the individual slide. Then there is, so GetMac basically provides us with the MAC address. MAC address for getting the device ID. MAC address is not the computer name, but rather it's a device ID which is unique to this motherboard. It's not unique to this computer, rather it's unique to the motherboard itself. Every motherboard with an internet connectivity associated IC, which is called as the Northbridge IC, each one is assigned with a unique MAC ID, so that every MAC ID in this world becomes an unique one. No two MAC IDs are equal, no two MAC IDs are similar, because creating a similar MAC ID will create forgery in the system. Anyone can create a system where, what I can say, everyone can create a online transaction, camouflaging within the MAC ID of any other person if MAC IDs were same between two numbers. That's why MAC IDs are not equal. Okay, so that's the way the international system has been designed. So next is name server lookup. Name server lookup is for identifying your computer's domain name server or your computer's main host ID or main host IP. Here you can see it's telling us with the NS lookup. Let us go back to again and try to find out our own domain name server or the network server lookup, name server lookup. You can see your default server is CCTV and its address is 11.0.0.1. So that means it's connecting to the server or it connecting to the router where this LAN connection is provided. So you can have an idea that this is where what I am doing in real time, and when I was doing it from my laptop, when I pressed ns lookup, it provided us with a default server unknown. Unknown means its name is not obtained from the server list, and its address was 192.168.0.1. Why? And when I am doing that from the desktop itself, what I am getting is a CCTV with an address of 11.0.1. Why this difference? Difference is because when I write down the name server, it automatically fetches the details from my nearest router or nearest switch, or from my nearest hub, or from nearest bridge. So for this case, when I am doing it from CCTV, I am actually connected to my LAN, and that LAN is named after this particular connection, which is called as the CCTV. Maybe because this LAN connection was built for providing with the authorization of CCTV network that has been placed in our university building. So I am using internet through that CCTV network, and it has been provided with a class A IP address of 11.0.0.1. Whereas our when I was doing it from the router itself, from my B3 third floor faculty room, what I got is nearest server to be, or nearest switch to be, the Wi-Fi router that has been installed in our room itself, and its name has not been set, its name has not been provided with the address of 192.168.0.1. Now you keep in mind that when every switch that is installed in our LAN or in MAN, every normal Wi-Fi router switch, the normal Wi-Fi routers which are having some antennas in it, those Wi-Fi routers have a default configuration or a default server IP address of 192.168.0.1. You can check for yourself, placed in anywhere in our university building under connection of any one of the routers that are placed throughout 3 of the buildings, and you can try to place this ns lookup command. You will find that the default server name may be different based on whatever the system engineer or the system manager has provided the name of the individual router, but the address will be 192.168.0.1. It is a default IP address or a default domain name or the default IP address for individual Wi-Fi routers itself. Okay, so that's, you can check for yourself when you are in your own connection and try to see what this command is actually reflecting. Then to the next, it's the netstat. Let us find out what does this do. This is our command prompt, netstat. So network statistics, again it's showing that server is CCTV and address is 11.0.0.1. So it's because I am connected to a LAN, I am getting this connection service that is being provided with the netstat or the network statistics window. And because each one of the computer is hidden from being discoverable, that's why no internal type for both IPv4 and IPv6 addresses have been provided. Here you can see that all the computers have been configured in such a way that everyone is not sharing their own IP addresses. That's why they have only accessed this default switch where I am connected to through the LAN connection. That's why I am not getting any other thing that is available. But whereas netstat was providing us with different computers when I was using Wi-Fi connection. When I was using Wi-Fi connection, as you can see, I was using my laptop for providing this netstat connection, and you can see here all the computers which are connected through Wi-Fi, that all were connected or that all were being shown using the command that I used in my laptop itself. So it depends on where you are connected to, it depends on which connection you are using and which are using Wi-Fi connection or LAN connection for implementation. So that you can see for yourself. Next is netshell or netsh. Netshell is a network shell. It's like a DOS window within a DOS command itself, within a DOS prompt itself. So network shell is a cell is a specific area where you can execute different commands for checking different network operations. As you can see, when you have run netsh with a slash and question mark command, it shows list of commands which are available in this netsh. Now for let me just show you one thing. So when I write down netsh, I go directly to, rather let me just Ctrl Z it. So I am within the UEM itself, I am within the C users UEM directory, and I put down the command netsh, and now I am within the netsh cell itself. I am not within the C users UEM, but rather I am now within net cell or the network cell cell itself. I can now execute any other command. So netsh, then with this one, okay, so it's not within the cell itself, but rather netsh, then slash question mark. It shows these types of command I can use when I am within the net cell itself. So like adds a configuration entry to the list of entries, advanced firewall changes to the netsh add firewall context, anyone firewall changes to the netsh firewall context. These all are the commands that I can use while and like this winsock, then win http, then wfp, then wsn trace, then show, set, rpc, ras, p2p, netio, netio, namespace, mbn, everything that is available. These all commands are available when I am using the net cell itself. So let us check for one command. Let's say write down firewall, and you can see that firewall related command is showing some of the commands that are being reflected by the netsh firewall command itself. It's showing that in the future versions of Windows, Microsoft might remove the netsh functionality for Windows firewall with advanced security. That means it's showing that for the future versions, this DOS command will not be able to access the firewall related commands because of the security issues, because DOS was having a very earlier command prompt Windows, so they were not that much amount of secure, and that's creating the problem itself. So netsh firewall, again I can write down and see within the firewall command itself, these are different commands that I can see. These are different commands that I can execute to change in the firewall itself. Okay, so within the firewall netsh command itself, so now I am within netsh firewall cell itself. So it's a subcell that I am using now on, and within the subset itself I can write down all the individual commands. So DHCP CLIENT, let's say dynamic host controlling protocol. Now I am within the DHCP client itself. Okay, then I can write down VLAN, I can be within the VLAN itself. So those who are advanced system managers, they can access all the individual features from their tip of this execution command, this command, and find out all the individual commands that they can execute and change the system parameters. I am not going to do that because it may harm or it may change some of the properties of this computer, so that will create some nuisance, because we take classes from this computer itself. So the netsh is a very detailed command, it's a very advanced mode command which are being used by the network managers for changing the properties or the configurations of the computer. Okay, then next is an ARP command, or the address resolution protocol. What it intends to display or manipulate the ARP information on a network device or a computer. Okay, so it, and again advanced level command where it shows address resolution protocol. Address resolution protocol itself is an advanced level command where you can change the IP addresses or change the subnet masks or change the IPv6 addresses of your computer itself. You can put your command and see what are the different sub commands that you can put it for manipulating the IP address related operations in your computer itself. So I am not going to also change those things, but you can see for yourself what are the commands that you are capable of getting into in your computer itself. Then there is another command which is called as the finger. It shows us the information about a users on a specified system running the finger surface. Output varies on the remote system. So it allows the personal information. It tries to find out from which computer I am trying to say. I am writing down finger google.com. It's only showing my computer's name, right? So when I am trying to connect it to the google.com server, they are simply refusing the connection. Okay, so I can only write down the finger command itself and see for yourself what are the different commands I can associate with the finger command itself. So you can see if I provide a -l, it shows us with a long information. Then user specifies the user you want to information about. So if you can omit the user part, then you get the full list of information. Like I said that FINGER 192.168.0.1. Okay, sorry, I have not provided the space. It's again showing that desktop is being connected and it's trying to connect to the other service, but it's being refused. Okay, so those who are using Linux laptops or Linux computers in your home or in your place, you can check for yourself what the finger command is reflecting. And for me it's only showing my computer, but whenever it tries to connect to the other user that I am trying to see information from, it basically saying that the connection is being refused by the other computer itself. Okay, next another. Okay, let us go back to the 9th. So finger command is there. Next is net view with the IP address or with the computer name. So let us check again, for example, with a hands-on approach. Net view 22.168.0.1. Okay, so net view it's not being used by the computer itself. So net view is not available in our version of the Windows itself, because it's the most latest version .1.1. Let's try to find out. So net view is not available in our computer, but sometimes in older computers you may get information about the whole list of resources that are connected to this network itself. Next is another computer, there is another one which is NetSL, then WLAN show profiles. It shows all the WLAN that has been connected to. Let us take this one. It's a very interesting command which you can see for yourself. So the command is NetSL, that is NetSH WLAN, then SHOW PROFILES, so profiles. So for this case, unfortunately for this computer I am not getting anything, because wireless auto configuration service is not running. So my computer is connected to wireless, wired LAN. Okay, net is then I've got two questions. So net sh diye shop passwords dekha jay, right? Only you can see those passwords which are your own secure connection, right, obviously. So we have to write net space view then computer name. Okay, no problem. Net view. Okay, if that is the case, let us find it that way. So because NetSH or the NetSL wireless LAN show profiles is not showing us anything in our computer, so this is the screenshot of my computer. When I had taken this command, it shows all the individual wireless LAN that are connected to this wireless LAN and wired LAN in various places. Like you can see, there are many access points: B3 third floor faculty room 5G, Redmi 9A, Poco X2 registrar room, B3 third floor faculty room, placement cell, Realme C2, Realme 5, Redmi Note 5 2, then Redmi Note 5, and all individual Wi-Fi connections which are using this CCTV connection as their base. These all Wi-Fi routers are basically connected to the CCTV LAN and they are being used. Because my laptop was connected in WLAN, that's why these profiles have been shown in my laptop itself, because my laptop WLAN connectivity was activated. But for the other case, because I am using a desktop and my desktop, the wireless LAN is not activated at this moment, because there is no such chip at this moment present in my desktop motherboard. That's why it's not able to show me the wireless LAN profiles that are connected to. Okay, so here for our case, when we have provided net view, you cannot connect to the file share because it's not secure. The share requires obsolete SMB protocol. So that means there must be something different that we are doing. So let's take another example and try to find out whether we can get anything or not. So these are all, because they are all in hand approach, in hand live execution approach. You can directly check for yourself. It will return something different in your computer. It is returning different in my laptop as well as in my computer yourself. So it will automatically define everything that is being connected through that particular network path and will depend on that or it's only itself. So let us find out 11, if I can remember correctly, .0.0.1. It was the CCTV network. So there is a network error because it's not providing us with the path, it's not giving us, let's say 127.0.0.1, because it's the default connection, that's why it's not showing. So let's check another IP address, 192.168.0.2. let's randomly take another IP address and try to find out. It's not a default domain name server or the default gateway I am not covering. Let's see. In the meantime, let us go back to other profiles. So this is the net SH or the net shells WLAN show profiles. It shows us all the WLAN which are a part of this wired LAN that I am connected to. These are all control panel related commands like ncpa.cpl network setup, net setup.cpl. This CPL extension shows us that these are a part of the control panel properties. So network setup is a wizard, network connections, control net connections. These all are separate commands which can be used in DOS mode, in command prompt mode, to check all the individual properties of the net connection itself. Now in the Linux also similar types of configurations can be accessed, like one is IP. This IP is one of the most major commands which are available in Linux. In the meantime, let us go back and check for ourselves. So network error 53, that's because our connection is secured. That's why it's not able to find out the properties of the individual connection that we are trying to find. Okay, because this is one Windows command and I am not used an emulator to see what the Linux command will look like. So let us go directly to those commands and try to see what they returns in general. So this one is one IP. It basically returns with the IP address that you are using in your computer itself. Then IP link. This is for configuring, adding and deleting network interfaces. Like this example shows, if I have provided with a $sign is the default command prompt sign in your Linux terminal emulator. So IP link show, it shows all the details. Now remember that when you are providing any command in your Linux, the Linux is much more robust, Linux is much more detailed because it's an open source system. That's why it shows us with all the detailed reflections that we are getting from the command prompt itself. So they shows much more information in comparison with the DOS itself or command prompt itself, because it's an open source operation. So we can get more detailed output from individual Linux commands that we provide. So IP link show is one command that you can see these every detail, whether it's a broadcast, whether it's a multicast, whether it's an up, lower up, all the individual types of information is available in our computer if you provide with the IP link show. Every detail related to your IP will be shown there. Then another one is IP address show with the computer name itself. So this part is the computer name itself, it's the randomly generated number, and this is the development or the developer part of the computer itself. So IP address, so this is your exact command, and with the computer name it shows the IP address. So our IP address, the IPv6 address becomes this one, whereas IP address for our IPv4 address becomes this one with the class ID of this one, or the class number, class maximum amount of values of computer that can be connected, out of which your internet connection has this IP address that will be shown by this IP address. So then another one is IP root. It's like the trace root, or it's like the path ping command. It shows us with the class IP root, it provides us with the same way, it provides us with the mapping. IP root, you can see IP root show, this is the command that we have put, and it's showing the default route that it has followed in the computer dev, this one, with the IP address of 10.0.2.2. it's a class 1 IP address. You can see its default values with the nearest node that has been provided here. So these all are the nodes that it has. Okay, sorry. So these are the individual IPs that it has been connected to, and with this one being the detailed information about the kernel of the computer itself. Okay. So the way the computer has connected from one computer to the other computer, so this one has connected to this one, and then another node it has been taken for finding out the path to this one. This all detailed information will be available in IP root. Then another known command, which is trace root google.com. So it's showing all the individual nodes that it has taken for sending the documents, sending the packets to the google.com itself, and you can see there are a lot more information being provided by the Linux command when it's being executed in comparison with the DOS command itself. So the detailed information, you can see these all are individual nodes that it has followed with the delay, with the time taken for the getting the acknowledgement, with the time taken between the sending and the receiving acknowledgement and everything. Then TCP dump. TCP dump, as you can see, it's a packet sniffing tool and can be used of a great help when resolving network issues. It listens to the network traffic and points packet information based on the criteria you defined. Prints packet information, that means whatever packet is being sent and it's being received at this moment by your computer, those all individual packets will be traced, all individual packets will be calculated, and you can see them in the display itself. Now how many packets you will be getting to see, or how many packets will be reflected in your output, because unless and until you are specifying that, it will go on doing the same way, reflecting all the individual packets that has been transmitted and received. at this moment, and you have to specify how many number of say you can see here that the actual command is sudo, then tcp dump, then host, then ubuntu 18, the device name with the 5 number of packets. So for 5 packets it has asked the computer to dump TCP IP addresses and its details. So you can see 5 packets have been captured, 5 packets have been captured here. So the 6th packet means one is initial bit, one is the initial package which is not taken into count, but you have specified 5 packet, that's why it has taken 5 different packet, and its details regarding those individual packets have been shown. Then there is netstat, which is exactly like the way it does in the command prompt itself. Netstat command is used to examine network connections. You can see here netstat I information, netstat information is every detailed about the network connection is shown here. Now because this one is an example I am using, I also do not know what are the individual values that it's providing, but instead you can see here that one is Ethernet 0, another one is Ethernet 1, 2 Ethernet connections which are available through that particular LAN, and this one I do not know from which they have taken this example, but rather these 3 different network connections which are available and their individual details have been provided here itself. So without understanding where it's being connected to, you cannot say all the individual informations at this moment. Then services, so for different services you can access or which port they are using for transmission of data, which port they are using for receiving of data, that all you can see and you can listen to by writing down services as SS command in the Linux. Those of you who are using Linux, you can check for yourself. Then SCP and SFTP, this one is a secure copy command where you can use that in terminal emulator to copy securely some of the network informations, copy securely some of the network configurations for your own purpose. Okay, so it will be saved in a text file, and that text file will hold everything that is written within a specific connection. Say for example, you are trying to know the password of a WLAN where you are connected to, and you can write down SCP or SFTP and trying to find out where with the by providing with the name of the computer connections and try to find out the password by converting it into a text. So you just create a text document by writing this password, I mean writing this command prompt or writing this command, and everything details as per your WLAN configuration will be stored in that text file. Then ifconfig, it's also almost the same way, that's used in the Windows or ipconfig. So it shows everything, every detail related to the computer configuration which is using internet through which you are executing this command. Okay, so it's showing everything. What are the IP addresses, what are the broadcast addresses, what are the MAC addresses, what are the connections it is using for transmission of data, what are the different values of the loss, what are the different time that it has taken for sending and receiving of the acknowledgement bits. Every detail you will be able to get using the ifconfig operation. That are all the Linux and Windows commands that you need to do or you need to put forward in your assignment. Now it's 3:58, so we will be closing for today. So next week if I take the class, we will be going through the configuration of a server client operation using a packet tracer. So that much for today. Hope to see you in tomorrow or in the next day's class. Thank you for joining. Have a nice day.